In this video, I'll be going over functions and function notation. So we say a function is a relation in which each possible input value leads exactly to one output value. We say the output is a function of the input. So a simple example of a function is, think about suppose you're in a room of 20 people and everybody in the room is asked, when is your birthday? Now, each person would think about that, and they would respond by saying exactly one day for their birthday. So suppose student A, their birthday is October 1st. Student B could say their birthday is September 12th. Student C or person C could say, May 29th, etc., all the way down. And let's say there's one more person, supposing I'm going in alphabetical order, say it's person M, and they also say that their birthday is September 12th. Now, this would represent a function because each input would be the person, and the output would be when their birthday is. And so what we would say here is that each input points to one output. So each input points to one output. Now, because person M also had the birthday of September 12th, two people would point to the same output. That is okay. This would still represent a function. It's just a different type of function where each output is coming from only or a unique input, and we'll talk about what that represents. But for something to be a function, each input goes to one output. This situation would not be a function if we were to say something like person A has two different birthdays, October 1st and July 12th, for example. We know that doesn't make sense. People only have one day that they were born, so that's why that situation represents a function. So let's look at these three tables or images here to see which ones of these are functions. So the first one, on the left column, I have all of these x values, and each x value points to one y value. And again, if we look at all the y values, there's not multiple x's that are pointing to the same y value. This is different than what we saw up here with the birthdays, where we had a single birthday that was shared by two different people. So this image, we would say that yes, this represents a function, and the type of function when each output is coming from a unique input. In other words, each output, each y value, only has one arrow pointing to it. We say that those types of functions are one-to-one. Okay, the second image, this would also be a function because each input, all the x's, have one arrow coming from them and they point to a single output. So this is a function, but because y2 is coming from two separate x values, we would say this is not one-to-one. That would be like two people sharing the same birthday. And then the last image here, this is not a function because this x2 input points to two separate outputs. So that's one way that we can represent functions with these input-output tables. So another way that we can represent input and output is with a numerical table like this. And so this says the notation y equals f of x defines a function named f. So whatever this is what the name of the function is. This is read as y is a function of x. The letter x represents the inputs, or the independent variable. The letter y, or f of x, represents the output variable. So let's look at these tables. Which of these represent functions? So this first one, I have an input of 2 that points to one output. Each of these point to one output. So in this table, when I input 2, 5, and 8, I get a different output. So yes, and this is one-to-one. The second table here I have two of the same outputs that are coming from different inputs. So again, two people, same birthday. This is a function, but it's not one-to-one. And then lastly, 5, when I input 5, I get two different outputs. So that indicates that this is not a function. All right, so hopefully that's pretty straightforward. Now let's look at how we can evaluate functions when they're given to us in algebraic form. So in algebraic form, that's just when we write it as an equation like this. So for number 1, it says we want to input 2 into this function. So what that means is we're going to say f of 2. And I'm using f because my function is f. And whatever is in the parentheses is what the input is. So I'm going to input 2 wherever the x is. And when I do this input, I want to use parentheses. So when I do that, I get a value of 6 here. The second one, I have f of a plus h. So we're going to input a plus h wherever the x is. Okay, simplifying this down, what we're going to get is a squared plus 2ah plus h squared. I'm going to run out of room here. Plus 3a plus 3h minus 4. And so I get 1, 2, 3, 4, 5, 6 terms. None of those terms can be combined. So f of a plus h would equal those 6 terms. This third one, I'm going to input a into the function. So this is a squared plus 3a minus 4, and there's not much else to do on this one. And then the fourth one, I have f of 1/2. So 1/2 squared plus 3 times 1/2 minus 4. And what we get here is 1/2 squared is 1/4 plus 3/2 minus 4. Getting a common denominator and combining this all, we're going to get negative 9/4. So I'll let you simplify that down and make sure you get negative 9/4. Okay, this next example is quite similar. Why don't you try that one on your own? So hit pause on the video, see if you can do it, and then press play, and I'll go through it. Okay, so h of negative 3, I'm not going to go through this step by step, but this comes out to 32. H of y squared, this is going to be y to the 4th minus 7y squared plus 2. Number 3, h of 12. That's going to come out to, I can't do that one in my head, 144 minus 7 times 12 is 84 plus 2. So what is that? 62. Okay, and then the last one, h of square root of 10. We're going to get square root of 10 squared minus 7 times square root of 10 plus 2. Square root of 10 is just 10, so this is 10 plus 2 is 12 minus 7 square root 10. Okay, so that's some pretty simple function evaluation. The next thing to discuss is how we can tell whether the graph, or tell whether a given graph represents a function, and we can do that with the vertical line test. So the vertical line test can be used to determine whether a graph represents a function. If we can draw any vertical line that intersects a graph more than once or in more than one spot, then the graph does not represent a function. That's because what does it say here? Because a function has only one output for each input value. In other words, each input can only point to one output. We usually say that x is the input and y is the output. So here, or let me say, if this is my x value, this is my y value, and the y value is the output. So no matter where I am along here, I can draw up to the function, and it's going to map over to one value on the y-axis. Okay, I don't know if those lines make sense. But here on the second one, if I input, looks like 3 here, if I input 3 into the function, so if x is 3, I'm going to get this y value, and I'm also going to get this y value. So this is not a function because when I input 3 into the function, I get 2 different y values. Similarly, when I put it into this function, I get 2 different y values. So not a function. So that's a quick way to determine whether the given graph represents a function if it passes or does not pass the vertical line test. And if you have an algebraic function or an algebraic equation like something like this, if you were to graph that, you could quickly determine whether it's a function by using the vertical line test. All right, and then we just have a couple more examples here. Again, why don't you pause the video and see if you can solve these, and then I'll put the answers down here in a moment. All right, so this first one, k of 2, when I input that into this function, k of 2 is equal to 6. K of negative 3 is also 6. K of a plus 3 is a squared plus 7a plus 12. And then this function down here, h of 5, that's going to be 87. H of y squared is going to be 15y squared plus 12. Then this last one is a little different. It's saying h of x is equal to 37. Well, if h of x is equal to 15x plus 12 and h of x is equal to 37, that means this and 15x plus 12 must be equal to each other. So what we want to do is we want to solve this for x. So subtract 12 from both sides, 15x equals 25. X is equal to 25 over 15, or 5/3, and that's it.